Hi everyone, my name is Sumaya Ahmed, and I am the Virtual Content Specialist for 7th grade science. This video will review how to make sense of line graphs and analyze the information line graphs provide. So graphs help us organize and analyze information in an easier way. They can show trends, relationships between variables, accommodate large sets of data, and can compare data all in one form. And graphs are created based on a data set. For example, here we have a data set for temperature data for Seattle, and you have the date, the highs in degrees Fahrenheit, and the lows in degrees Fahrenheit. So this table does not really give us a visual of what the data is showing us. We would have to look at every single value for each of the dates and take some time to look at to analyze trends. But if you can graph it, then it looks like this. This gives you a quick visual of the data. It organizes the data set, so you have all of these values organized on the x and y axis, and the highs and the lows are broken down into two colors, and there's a key over here. And automatically, this can give you a lot of information without even looking at the data set. So let's say you want to plan a trip to Seattle when it is a little warmer. You would look at the data, you would see the high temperatures. The highest one is around 60 degrees Fahrenheit around March, and that's when you would plan your trip. So as you can see, graphs are very helpful in organizing data sets. So here is another data set. We have the effect of temperature on plant growth. There's a temperature in degrees Celsius on one side, the values on one side, and the values for the plant height corresponding to each temperature. And again, this would be difficult to analyze because you have the values, you have the plant height, even though you could determine what would be the best temperature for the highest plant height. However, if you graph it, it will give you a better picture showing you the relationship between temperature and plant height. So again, graphs help show relationships and analyze information from data in an easier way. So this is a graph from the lesson, and I'm going to go over the steps on how to understand a graph. So the first step in understanding a line graph is to look at the title. The title tells us exactly what to expect from the graph. Now, there are three titles to a graph. So the main title is usually on top. Over here, it's carbon emissions. But then there are two more titles. There's an x-axis title and a y-axis title. So the x-axis title is a horizontal side, and it tells you the name of the values on the x-axis. So here, our values are showing the year. So our title for the x-axis is year. And the y-axis tells us what the values on the y-axis are for. So here, they are showing carbon in million metric tons, so million metric tons of carbon. And that's our title for the y-axis. So the first step, again, is to look at all three titles, not just the main title. One thing to be mindful of is that the x and y-axis titles should have units of measurement. For example, the unit of measurement for the y-axis title is million metric tons. So they didn't just write carbon, they wrote million metric tons of carbon. Sometimes the units are in parentheses after the title. The next part to note are the scales. So most graphs come with a scale with the values along the x-axis and y-axis. So here we are showing carbon emissions, and the scale is from year 1900 to 2010. Okay, and each tick is increasing by 10 years. So you have 1900, then 1910, 1920. And then the scale is different on the y-axis. So again, the scale on the x-axis is every 10 years. The scale on the y-axis is a million metric tons, and it's every 1,000 million metric tons. So you start from 0 and then you go to 1,000 million metric tons and then 2,000 million metric tons and so on. And this helps you, these scales help you plot your data from your data set. The points of the X and Y coordinates based on the data, for some, there may be just a line here, but the next step that you should look at are the points. Now here, there are no points. So this graph just has the line, the trend line. Some line graphs you will see will have distinct points, and those are your data points, your X and Y coordinates. And we can also have a double line graph where there are two X and Y, there are two Y axes. Okay, there's one X axis and there would be two Y axes showing you two different values. So let's look at that example here. So here we have the main title of the main title on top, CO2 levels versus volcanic activity. And we have the x-axis title, which is the year. Again, this is every 10 years, 1960, 1970, 1980, and so on. And here we have two y-axes, and we have different values for each. So on one side is the axis for the atmospheric carbon dioxide. And again, our units are parts per million. Remember I said they could be in parentheses. Okay, so it's 280 parts per million, 300 parts per million, 320 parts per million. And then over here, on the other side, we have the power of the volcanic eruption. So it goes from 0 to 0.05, 0.1, 0.15, and it says a power of volcanic eruption measured by the amount of ash in the air. Okay, so they're measuring the power by the amount of ash in the air. And these are the values to represent that. And on the graph here, it specifies with the y-axis value which one corresponds to which y-axis value. So for example, the red line is the atmospheric carbon dioxide, because it says Mauna Loa Atmospheric Carbon Dioxide Measurement Station. So that is measuring the atmospheric carbon dioxide in parts per million. And over here, this is showing the power of the volcanic eruption by the amount of ash on the purple line here. So if there's a double line graph, they may have two scales and they will put labels on what each line represents. So here is another example, a little bit different. We have the x-axis title here. The main title is not on top of the graph, but it's in the middle of the graph, global temperature increase since 1950. And then you have your y-axis title over here on the top, and then you have your y-axis title on this side on top for temperature change versus concentration of carbon dioxide in parts per million. And as you can see, there are two lines and they are differentiated by their color. So the temperature change line in degrees Celsius is red, and the concentration of carbon dioxide in parts per million is in purple. So to summarize, when analyzing a line graph, always start by noting the titles, the main title and the axis title. So you have your x-axis title and your y-axis title. All that gives you information about what this graph is about. What is this graph telling you? Step 2 is to look at the units and the scale for the x and y axes. So look at the numbers. Here it is the year increasing every 10 years. Here it's the metric million tons of carbon, and the values are going by 1,000 metric million tons, and it's increasing by 1,000. Lastly, look at the data points and the trend line. So based on the year versus the tons of carbon, what is this line showing you? How would you read this line? And you can look at the relationship. Usually line graphs show some form of relationship between the years and the tons of carbon that's emitted. And you can get all this information by combining all the steps from understanding a line graph. So to elaborate on your learning on line graphs, I challenge you to create a line graph based on a data set using the steps discussed in this video. So I wish you good luck on that challenge, and thank you for watching this video. Bye!